Rough as a cob. That one locks up occasionally. Doesn't sound good. Get a lot of noise out of that drill press this way. A lot of noise out of that drill press by replacing all of these. Remember this? We were out and about. Went to visit one of those antique places where everybody rents a space. And we went there because I knew there was a special dealer there. Check this out. I got this out of there for, I think it was $3. This is a 3/4 16. This particular antique place in Springfield, Ohio has a tool dealer in it. And he's got a whole lot of taps, fair amount of taps and dies, but a whole bunch of Craftsman screwdrivers. And I bought several of these. This is a Phillips and a slot. And my goal for the Phillips and the slot was to put the slot screwdriver in here because everything I have is too long. And look what my problem is. It doesn't fit down in the slot. So I found a short enough screwdriver, but I didn't think about the handle being too fat. So I guess I'll have some extra little screwdrivers around. I could be a fun project. Chuck this up and machine this into something smaller. If I need another one, maybe I'll do that. And I did buy one of the standard ones that I was pretty sure, I didn't have anything to measure with there, but these are always about 3/8 of an inch too long. And of course the handle's too big. So I can't get that in there. But that screwdriver was $1. These pairs were $1, so I'm not hurt. But I found something else, and I bought it just in case. This little thing here was $1. And in here is a level. And another little screwdriver with a really small handle. So check that out. So I have something at least that fits in here a little better. So we got that covered. Got this for $2. A general deburring tool. And this springs back and releases the ball detent. So now I have another deburring tool to put in another location. That's got a good feel to it. I didn't know General made one of those. That was $2 as I remember. This is a dolly, and I've had several times, this was $6, so a little bit of a splurge. I've had several times when I've needed a dolly when I've been trying to straighten out some sheet metal, and I don't have one. And I really wanted, you know, some American tool, not what Harbor Freight sells. And this is probably much better quality than what Harbor Freight sells. And I don't know what this tool is called. We'll call it a tombstone. There's another shaped tool I need to find, and maybe I'll run into one of those. But I thought that was a fair deal for $6. Almost looks like there's a letter in there. And, oh yeah, another one of those dollar sets of screwdrivers. Check this out. That's everything in the bag. There was a display there that had cut off pieces of oak and cherry. And most of the cherry pieces this size were marked $1.95. This one was marked 95 cents. And these were 95 cents a piece. So I've been needing some oak for a special project. Might be part of a YouTube video because I need a chunk of wood that's got some weight to it. And the cherry's actually kind of heavy too. I might be able to use the cherry, and that would be kind of neat to do that too. So, future project. Look at that beautiful tap. No chips. Feels nice and sharp. Bargain. Got a 3/4 10. That one there is a 3/4 9. This is a 3/4 16. Didn't have one of those. I just bought it because it was a bargain. I wasn't sure I needed it, but there we go. Had an interesting experience. Had to use some the water remover for my truck. Well, this kind of bottle makes a really great funnel. So I'm going to save one of them and put it on the wall with my funnels. See if I can get that just a little bit level. It's nice to have a funnel with a long neck so it will hold in something. This would get in a nice tight spot. Maybe to. Here's our two bearings off of the quill. A little bit rough. And here's the two replacements. Silent. Let's see, this one's a 6201 RS. And this one is a 62, ooh, I'm going to have to read the box, it's awful small, 6202-2 RS. So, there we go. I'm going to press these on. I'm withdrawing the jaws so I can press against this surface. Let's go press this bearing on here. Now the bearing, it's important to notice that these are the bearings that came out of it. They removed the seals that were on the inside facing each other. But that does allow the grease to come out of them, even though there is lubricant. But still, somehow or another, dirt and stuff gets in these. Possibly from the casting and stuff that they leave in from manufacturing. They got a seal on top, but on the bottom they have a shield. And a bearing shield, it does not touch the inner race. There's a gap. You can see I can get the point of my knife in there. And dirt can eventually get in there. Now, they turn a little freer when they're shielded versus sealed because there's not a rubber lip running on that. But I'm interested in longevity, and they're going to stay cleaner if they're sealed rather than shielded. So let's go push this one on the arbor press. Here's my Greenard #2 arbor press, and we'll use this to push the bearing on. Just like that. Well, I started driving this together and realized the camera wasn't running. I used a washer that's slightly concave, which means it's sticking out more here in the middle than the edge to push against the inner race. As such, and I still have to drive on a little more because I've got this bearing pushed out down here a little bit. So driving on this now that that bearing is fully seated is driving the outer quill here around the bottom bearing. Now I think it's seated. Yeah, that bearing's all the way in there now. A little bit sticky. Let me shock it. There we go. Now we're loose. So what happened there is the distance between... Oh, I know what... Okay, so what happened there, the inner race of this big bearing is seated out against a step here. The outer race is seated out on a step in here. The outer race here is seated out on a step in here. And then the inner race there's a little bit of play in a bearing, I had it driven hard against the balls. So by hitting this just a little bit, it allows that to equalize so the balls aren't pushed to one end of their run. So that's beautiful. New bearings, be nice and quiet now. This is the driven pulley mount. Installs in the head of the drill press up on top, and then the driven pulley is connected here on the taper, and there's a nut that holds it on the taper here. And in here is a spline, and as you run your quill up and down, it keeps you connected to that pulley so that you can drive the chuck and turn your drill bits. Well, this part is the only two bearings that I haven't replaced, and they're also 30 years old. They don't sound terrible, but you know, these things are cheap, like, I don't know, $1.25 a piece. I just ordered 10 of them for $12 delivered. So really less than $1 a piece, and I'll be satisfied knowing that I replaced them all. 6203 RS, which is a 40 by 17 by 12 millimeter bearing. So this is going to bring this project to a stop. This is the only bearing I only ordered 2 of. I didn't order 10, and I used 1 here in the quill assembly, but I only have 1, so I need another one to replace this. So instead of just ordering 1 bearing for $4, I'll order 10 for $12. So that'll bring this project to a stop until the bearings get here. Here's my nicely refinished head to the drill press. The only thing I didn't paint here was the interior of the belt guard, and the reason I didn't is I couldn't get that decal off. Notice it's already set up for an intermediate pulley here, so it's possible you could upgrade and have a 2-step pulley system. And the way you do that is you have another cone pulley, if you can get a matching cone pulley. There's a shaft that just slips down in here. It has a plate that comes over so far, and then another shaft that sticks up, and so it moves like as such, and so the shaft for the pulley kind of moves around an arc around this, and it allows you to get a lot more gear reduction. It would be fun to put that update on the drill press if I decide to keep it, but I would have to come up with a matching cone pulley. Well, since I don't have the bearings to finish the quill, or not the quill, the drive, gosh, what is it? The drive spline mechanism. I have one of these bearings, which just happens to be the same as one of the bearings that goes on the motor here. So let's go over to the Dake Arbor press. Back to this bearing again, very common bearing. Let's go back to the Dake Arbor press and press these on the shaft, and we will get our motor assembled. We'll get started on that. This is one of the darker, messier corners. This tube is too long. So here's my rig. Big end of the shaft in this tube. Tube is seated against a flat spot in the vise. That pushes on the inner race of the large bearing. Piece of PVC pipe pushes on the inner race of the small bearing. Bronze bushing material to push on that. And here we go. Okay. We still haven't moved the bottom one. I want to make sure I'm not fouling up the seal there. You know, this might actually fit in the arbor press now. Let me check. And back to the dark corner here, I've got some tool steel bars laying across the anvil plate. So that's resting on the center race. Got my bushing, aluminum tube, and I should be able to push it right together. There we go. I love arbor presses. It's a collecting habit of mine. There's a contact in here for the start windings, the switches to the run windings, and there's a little contact point right there. And if you can see that, you can see it actuating. And I've already swiped this with sandpaper a number of times, but you take a piece of sandpaper, fold it over, and close the contacts and put a little pressure on it and move the sandpaper, and that cleans those up. So we got that accomplished. Here's the center. And wires. And there's not much to do here. You saw me get the bearings pressed on. I guess I'm kind of wondering what's the front and what's the back here. So this is the bottom of the motor. I have another motor here as an example to look at. Oops. Put this through that way. I'll make sure I don't have any copper wire. Let's go and touch here. All that seems secure. There we go. Front on. I have an extra part here. Not even sure it matters. Put the front on. Put oil on the bearing here where it's going to meet with this mating surface in here. We don't want that to ever corrode and get stuck. putting the vent holes on each side opposite of the mounting plate. That way they won't be under the belt guard. I don't remember where all these wires go. I'm going to have to look at my old video. Well, you're watching me work through a problem here. When I took this down, I didn't video any of it, but I checked this capacitor. It was no good. And this capacitor is a new one that I bought. And it's basically the same size. And I see some marks here where I think possibly this one had been touching. I don't know, but the capacitor was on the inside and it was positioned something like so, and I'm trying to figure out how it was attached. It could have just been kind of trapped in here, you know, where it was just laying in there. I'm not real comfortable with that. I would like it to be secured to something. So I'm thinking about snaking a zip tie under the coils and kind of zip tying it right there. I'm a little worried. I don't want any roughness here to wear through the skin and cause some short from the capacitor to the coils here. So, you know, there's no, I'm not perfectly happy with everything here, but I think what I'm going to do is wrap this in some electrical tape. If you want electrical tape to stay on something long term, make sure you get some UL rated electrical tape, not some crappy Chinese garbage that you got because it was cheap, but something decent. And don't stretch it when you put it on. And if you do put electrical tape on something and stretch it, make sure you put an outside layer on that is not stretched. It's just kind of on there softly. Now I understand, you know, that's stretching is, or elasticity, that's one of the qualities of electrical tape that we're looking for. But it also, the glue slowly lets loose, and then the glue is transferred onto the area where the tape was, and then that's how that sticky spot develops, and you know, that's why we hate electrical tape very often. So I think I'm going to put it in that position. Let me think about this. Got to make sure wires reach. Could it have been here? Could have just as easily been there. I think we have more wire to put it there. I think that's what I'm going to do. And I'm going to zip tie it here to the copper windings. Might be a better solution, but this is my solution. And these zip ties will not be in the sun, so we don't really have to worry about them deteriorating and failing. But still yet, I'm going to put 2 in here, kind of double duty it. Wonder if I can get 2 in there. And you know what? I can Yeah, that's what I'll do. I'll get it secured at both ends if I can get one through here. All right. Let's do this where I don't have to push the nut through there. There we go. Turn it the other way. Go ahead and get these connected, one click in. Zip ties are a wonderful tool. What do you think of me now?